Okay, I think I'm sharing the correct screen now. You should see the text install packages here at the top and 2 terminal windows. And I don't know if people are ready to continue, hopefully. I first want to say I have 2 terminal windows here. I have one for Rackham and one for HPC2N. And in both of them, I am in my directory on this storage space. And on HPC2N, this is the path to the storage space. And on Rackham, this is the path. And you then create your own directory under it, as Björn said. I have also cloned the files, which is why I got the HPC-Python directory on both of them, and I'm inside that directory. Okay. Let's look at installing packages. And you will install the packages usually in isolated environments because they solve a couple of problems. That means you can install some older versions also, or specific ones that are different. Say you are working on Rackham and you have a specific version of NumPy there, but you need an older version of NumPy for some project, and then you could install that to an isolated environment. And isolated environments also means you can create one for each project, and it won't be a problem if the 2 projects need different versions. And of course, if you find out that you made some error in it, installed wrong packages, wrong versions, or if you just don't need it anymore, then you just remove the environment and create a new one. So it's a lot easier to do it that way than having to untangle the installations from your own computer or whatever. If you have just installed it directly, it's much, much easier to remove and create new when you have an isolated environment. Conda is one example of an isolated environment, but here we are going to look at pip with virtual environments. That is the only recommended way at HPC2N. At Rackham, as Björn said, you can also use Conda, but we're not going to talk about that today. Please look at the Bianca course if you want to hear more about Conda, because Conda is what you will be using there. And here we are going to look at isolated environments at Swedish HPC centers, and we are going to use the examples HPC2N and UPPMAX. And otherwise, this will actually be done more or less exactly the same everywhere. The only difference is that there may be different versions of Python and packages there, which you will load before you create the isolated environment and install stuff to them. So first, I will give a short theoretical introduction to isolated environments, and then look at some site-specific procedures. So, as I said, it could well be that you have several projects that use different versions of packages and even different versions of Python. And then you can use isolated environments. For instance, let's look at an example. You have used TensorFlow 1 for your projects, and now you need a newer version. And because you have a package, it requires maybe TensorFlow 2, but it doesn't mean that you don't still have stuff that you need to run with TensorFlow 1. And what do you do then? Well, you can create an isolated environment that is easily solved then. Because an isolated environment lets you create a separate workspace for different versions of Python and or different versions of packages. And you can activate, deactivate one at a time. And when a virtual environment is active, you can work completely as if the other workspace does not exist. So that is very useful. And as I said, there are different tools for creating isolated environments, but they all have some things in common. At UPPMAX and HPC2N, and also most other Swedish HPC centers that use modules, the workflow would be first, you load the Python module that you'll be using, as well as any site-installed package modules. And this parenthesis should be on the next line, I believe. You create the isolated environment with something like venv, virtualenv, or conda, and then you add the flag -- system side packages to tell that you want to use the site installed packages. And that's important to do because otherwise you will have to install everything, and that will take up a lot of space and is also simply a waste of time to download and install everything that is already there if it's versions that fits with what you use. So first check if there are packages, package modules that already suit you, and then only create an environment to install the things that you need to be different or which is missing. Anyway, you have created the isolated environment and then you activate it. And then you will then install or maybe update the environment with packages you need with pip install. And we will look at that in a moment. Then you do your work in the isolated environment, and then you deactivate the environment after use. And of course, much of this would even be the same on your own computer. In fact, everything would, except for the very first where you load modules, unless you are using the module system on your own computer. Then you would simply do this part of it. So what are the tools? Well, there is venv at UPPMAX and HPC2N. There's virtualenv at UPPMAX and HPC2N, and there's conda, which is only at UPPMAX. You can use conda at HPC2N. It is not installed. It is not supported because there are some problems with that on our module system. But you can use it if you absolutely want to, of course. venv and virtualenv are almost completely the same. There is some difference. That is, virtualenv supports some older Python versions, and there are some other minor things. venv is actually in the standard library, so it's already in Python. So if you have a virtual environment, you tailor the environment with specific versions for Python and packages so that you don't interfere with other installed Python versions and packages. You make it for each project so you have reproducibility. And there are different tools to create the environment. UPPMAX has conda, venv, virtualenv. HPC2N has venv and virtualenv. And again, remember, at UPPMAX, you can load Python directly. At HPC2N, you need prerequisites. And also, as mentioned earlier, the module is named Python with a capital P at HPC2N and with lowercase p at UPPMAX. So let's continue to more details. The virtual environment, venv and virtualenv. So first here, don't type along right now. I'm just going to go over an example here quickly. So I'm just going to show the difference of how it's done in virtualenv and how it's done with venv. And there is very little difference between how it is for HPC2N and UPPMAX here. The only difference is that HPC2N has the prerequisite and the different Python versions. So for virtualenv, first you load Python module or any prerequisites, and then you use virtualenv and you add the -- system side packages to make sure you are using the side packages, and then the name of the virtual environment. You can call it whatever you want, and I'm just calling it example here as an example. If you don't give a path, it will be created in the present working directory. Otherwise, you can insert a path in front of the name of the virtual environment. With venv, it's much the same. You load the Python module, if you haven't already, and then you use Python, because it's a standard library of Python, -m venv, and then again add the system side packages, and then name your virtual environment something. Again, it gets created in the working directory, unless you give a path to it. And the -m flag also makes sure that you use the libraries from the Python version you are using. So remember, to save space, always load any other Python modules that are needed and that you can find items installed or system installed before you install your own packages. It can take up quite a lot of space otherwise, and it also takes quite a lot of time to build. So reuse anything that's already there. And remember to check that everything is compatible. This is mainly a thing at HPC2N because there are several modules for the different Python packages. But also at UPPMAX, there is, of course, the Python ML packages that needs to be the correct version. So remember the flag -- item side packages to include the packages. In HPC2N, you often have to load what is called the SciPy bundle. It contains a lot of stuff like NumPy and other things. And this is an example that shows the ones that are modules that are compatible with each other. I mean, there is the GCC that you need to load the Python module. And then there's the SciPy bundle that is compatible with this GCC version and Python version as well. And then when you have loaded it, again, you create the virtual environment. So if you want it in a specific place, the only difference is add the path in front of it. And it's the same, of course, at HPC2N. And then you activate it with source, and then the path to the virtual environment, and then the bin directory under the virtual environment, and then the word activate, which is a program that activates the environment. And when you have done that, the prompt will change to start with example. And I could just show you what happens. So what I'm doing here is I'm loading the prerequisite of HPC2N. Then I'm loading Python. And then I'm loading SciPy bundle. If I'm sitting here and I have written SciPy bundle, I could press tab, and then it should have suggested something, and it won't until I actually load this. I will load this, and then I can do SciPy bundle, and I will get a suggestion for the one that is compatible by pressing tab. But it won't happen until you have loaded the prerequisites. So I load that. And then I will try and create this environment here, just to see what happens. So I say Python -m venv, and then I include the system side packages like this. And then I am going to create it in this directory here, which is my project storage directory, but not within the HPC Python directory. This is just to show as an example. And let's call it example. So I'm creating that. It will take a little while. more than a little while. The login node at HPC2N is actually slow. I saw that earlier. I will now go back one step to show how it looks here, and you can now see that I have a directory called example. That is where the virtual environment is located. Now I will try to go into it and show that there's now a bin directory under it. I will go into bin, and here I have activate, which is the binary file that will run to activate the environment. So let's go back up, and then I will source, and I could now either give this full path here, or I could just give the short path because I'm standing in the directory above it, but I'm just going to put the full one in here. So I say the name of the virtual environment, and then I say bin, and then I say activate, and I press enter. And as you can see, there's now example, the name of the virtual environment in front of my prompt here. So, and one thing to notice is that you can actually instead write a dot instead of source, and just make sure to have this space here in between. And I'm going to use source because it's easier to see on the screen simply. So, but it's equivalent. So what then if you want to install something to it? Well, you would say pip install, and then the no cache dir. That is to avoid reusing earlier installations in a different environment. And the no build is isolation is to again make sure it uses the loaded module from the module system. And that is mainly if you're building any site on libraries. So always include these things. And that is both at HPC2N and at UPPMAX and probably all other centers. So, and every time you need these tools, you simply activate the environment again, just like you did here. And I'm just going to deactivate this, and then I'm go on to we're preparing the course environment, and there I would like you to type along. So I will install the light GBM Python packages because I need it for one of the examples in the machine learning section later. And I would suggest that you also do this because you will need it for this example later. So let's try to do that at UPPMAX. And I will first do ML to see what do I have loaded. I actually already have the UPPMAX module loaded, but the reason for me loading it here is that sometimes when you purge the modules, you will risk that this disappears as well, and then it's a good idea to load it if it's not there. Let's see where I'm sitting. I'm in the project storage. I'm in my directory. I'm inside this HPC Python. And I am going to go up one step to just be in my project storage. This is not necessary. It's just me who has weird ideas about where I put stuff. So I'm going to put it here. So now I'm going to load these modules. So I will first, since UPPMAX was loaded, I will load Python 3.11.8. And you saw before I sometimes used ML just. ML is actually short for module load, so you can just write that. So I will try to do this here, and then I am loading this here. That is Python ML packages compatible with the 3.11.8, and it's for the CPU version because that is the one that is on Rackham. And then I'm going to create a Python virtual environment with venv. So I'm going to copy this part here. And then I'm going to put in my storage directory name here. And that is the user directory. And then I'm going to call it VPINV, so virtual Python environment, like this. Again, it takes a little while. Okay. And you can see it is there. So I'm going to source, and I'm just going to write VPINV because I'm standing in the same directory here. I'm going to say bin, and then I'm going to say activate and enter. I now am in this virtual environment. And as you can see here, it's much the same. The difference at HPC2N is simply different modules you need to load. And it is listed here which modules to load. Also, another thing is that you would need to install a little bit more Python packages because you need a different scikit-learn, because the version at HPC2N that is site installed is not compatible with that Python. So you also need to install that. But let's go back to UPPMAX. And since we are now in an activated virtual environment, we can install to it. And I'm going to use this command here, like that. And I actually need a number of, it didn't copy all of it. I need the GPM also. You can see it installs also scikit, build core, and CMake because those are needed as they are prerequisites, and that they were not included. And it got massively unhappy. Let's see what happened. Something is different to when I tested it a few days ago. Can someone from UPPMAX tell me if something has changed recently or if this is something you have seen before?
No, not really. So should one pin maybe the version?
But I think that since we are already, this looks right. I didn't have to tell what version it was before.
No.
Let's try just install these two to see.
But okay.
I just want to see where it is it becomes unhappy. If it helps to install them separately. Because it clearly got unhappy at the light GBM one.
Yeah.
So as you can see, that one went well.
Mm.
And I'm going to do a pip list to see what it says. And I'm also going to go check that light GBM has not gotten installed since I checked last. It has not.
Oh.
Okay, so let's try install light GBM and see what happens now. Okay, so it simply does not want it to be installed. You cannot put it on the same line, apparently. I haven't seen that happen before, actually.
No,
But,
not me either.
so what to do is install scikit build core and CMake first, and then do another pip install for light GBM. And
Yeah,
then
well, so I think so. If you try to install them on the same line, then this pip install tries to match the versions here, and it can find some incompatibilities, I would say. So it's try to to match the version
yeah,
all the
of course,
versions at the same time.
it should do that, but maybe it
Yeah.
cannot do it correctly unless the two other ones are installed first. I mean, that might well be. So it gets maybe there are some possibilities of conflict, as you say, and so it's easier for it to do it this way. But this works in any case. So I will just leave it to sit here, and then I will do the same thing at HPC2N of them for the simple reason that I need it at both places. So I will just quickly load this.
So I add some lines about this in the share document.
Yeah, and I will update this document after here also. This thing here, it just takes a while. Sometimes it takes a long time to build the packages. It has to do with how big they are, how much there is to download. But in this case, it's simply building it. So it just takes time. And now we will see if the same thing happens here. But it shouldn't, because LightGBM, it's a scikit-learn I need afterwards. So it should go well. But let's see.
So maybe we could try if the order of the libraries is important. Yeah.
It is, because when I installed this, I found that you need to install scikit build core and CMake first.
Yeah.
If you don't have them, then you cannot install LightGBM.
So it's not commutative.
No, it's not in this case. In some cases it is, but in this case it's not. And I'm guessing that maybe you simply need to have those two here installed before it can find the correct and compatible version of this one, LightGBM. I don't know, but I think that's the possibility. Anyway, it has finished here at HPC2N. So what I'm going to do there is to just say pip list. By the way, ignore the comment about a new pip available. So yeah. Let's now see if LightGBM is installed here. It is. You can see it's version 4.3.0. And now we have the environment that we're going to need for the course. So I'm going to deactivate it for now. And as you can see here, this here, the parenthesis venv here disappears when you are no longer in the environment. And that is a good way of noticing if you're actually inside of your environment. Let's try activate it again with source. And then we could open Python. And then we could try import LightGBM. And that went well. So that is fine. Okay. And this is still building. So always remember, every time you need the tools you have installed, or if you need to install new stuff, source it to activate it again. And of course, you need to load Python modules before you do the source here. Otherwise, you won't be able to access the site installed stuff. So how do you use this packages here? And again, I suggest you should type along. And I guess it will have to wait a little while because this probably has not finished building for anyone. I'm guessing it's also because now several people are probably building it on the login node. So, well, when it finishes, we can do this. And if you hadn't already loaded the modules, you would load the modules. You would source the project, the virtual environment, bin activate, and then you would open Python, and you would try import it, just like I just did here, the HPC2N. And you can do the exact same thing at UPPMAX in hopefully a very short while. So try do that, and then try deactivate it and see that you can no longer import it into Python, the LightGBM that you installed that is no longer listed in pip list. And I will just quickly mention that you could also work with virtual environments defined in files. And in that case, you would first create and activate an environment, just like we did above here. You would create an environment based on dependencies given in an environment file. And I will just go into here and show you that we actually have such a requirements file, just to show you how it looks. And I will just run it here. And this is just an example of a requirement file. And what you could do is you could create such a file from your present virtual environment. And I'm going to try and do that here. So I'm going to say pip freeze. And let's see, I have installed it here, as you can see. Good. So I do like this. And now it created a new requirements file. Let's open it with nano this time. And here you see all the packages that are in the environment and which versions. And you can see this includes also the one you just installed. And let's go out of this. Let's say that you don't want to see all the stuff that is site installed. You just want to see the stuff you installed yourself. So let's do it like that. And then I need to name it something different, of course. And now we only have the ones we just installed ourselves. And this is just the examples like I just showed you. And I suggest you simply do that, try and do these two commands where you rename this file, of course, when you are in your virtual environment and see the difference between the outputs you get. And if you want to read more about it, there is a link to a course they had at Aalto University in Espoo in Finland. And that looks at the dependency management from Python for scientific computing. So they actually have quite a lot of good courses. So, and then just one note, there is venv, and that is only if what you are doing otherwise is not enough. That is if you need, say, your own Python version, mainly. And there is some description about this at UPPMAX.
Well, it's not there anymore. It's removed now.
That's true. You have new web pages. Sorry.
Yeah, so use Conda instead.
Yeah. Okay. Use Conda. And also, you can use Jupyter in a virtual environment, of course. And there you could install Jupyter with pip install -I Jupyter. And this overwrites the version that is otherwise seen by the environment because there is a Jupyter. And then you could run the Jupyter Notebook, and you can use this at UPPMAX in order to get different versions or a Jupyter that contains different packages than the ones that would otherwise be on the site. And this is also possible to do at HPC2N, but the way to do it is somewhat different. So there are some guides here that you can follow in order to do that. But I'm not going to talk about this today. But the guides should be quite detailed, so you can try that later if you want yourself. And then just quickly, here is a list of the Python packages in HPC and ML, and this is just some of them. There are many, many, many packages, but this is simply a list of the more popular ones and which modules you would load at UPPMAX and at HPC2N. And I also have a short description of what it is. So for instance, say you wanted to use SciPy. It is already included in the Python module at UPPMAX, so you don't need to load anything else. At HPC2N, you need to load Python and the SciPy bundle, and then that's available. So you can look at this, and you can also try simply loading some of the modules there and do pip list and see what is included. So, and I should probably say that at UPPMAX, most of the libraries or the modules packages for Python is in Python, but there are also some in Python_ML_packages, and that one exists both for CPU and for GPU. So if using it on Snowy, you would use the GPU version, but more about later in the course. So, and there is some more information if you want it. UPPMAX has documentation pages about installing Python packages and about virtual environment. And HPC2N also has some documentation that you can look at. So a summary of the workflow. Of course, you need to load Python and often also some site-installed modules for Python packages, or maybe your own installed Python packages. So most of this would, again, be the same anywhere. The only difference is that under load Python and prerequisites, it might be different Python versions and different prerequisites. And then you load site installed packages if you need them, or if there are any that are installed. And then you activate your virtual environment if you had installed packages. Or if you want to install packages, then you install extra packages if you need that. Start Python or run Python scripts. Do your work, deactivate. And that is the standard way of how you go about when you are using Python and working with the packages you have installed yourself to a virtual environment. And then there is just a challenge example here, and I'm not going to look at that right now. So if you haven't already, I would suggest go ahead and get this course environment set up, create this virtual environment, install LightGBM and its prerequisites at either UPPMAX or HPC2N. And then if you want, you can try and do the pip freeze and then this arrow, which means that it sends the output to a certain file. So do that, create a requirements file, and you can try and do the same with the flag ---- local and see that it now only contains the packages you just installed yourself instead of all the packages. And then, of course, call the requirements file something different, because otherwise it will overwrite it. So, okay. And I think I should more or less continue directly to write